guys, and welcome back to a new course on Introduction to Statistics. This course is gonna be a really comprehensive course wherein we'll be covering a lot of different kinds of statistics that are used in the branch of data science and medicine, economics, psychology, and even genomics. So let's get started. So first of all, the main question that comes into our heads is, what is statistics? So statistics is a branch of applied mathematics that is dealing with data collection, organization, analysis, and interpretation. So there are many kinds of statistics. There is descriptive statistics and inferential statistics. In simple words, we can say statistics basically deals with the science of collecting and analyzing numerical data in large quantities, especially for the purpose of dealing with inferring proportions in the whole of those in representative sample. So it's just a mathematical body of science that pertains to collection, analysis, interpretation, or explanation and presentation of data. So we are just looking to present data as a branch of mathematics. Some people consider statistics to be a distinct mathematical science rather than a branch of statistics. So based upon different assumptions and all of that, we can just say it's just a branch of collecting data and then presenting them in a meaningful manner that it makes some sense to you. That's all about statistics, the basics introduction of statistics. So it's analyzing graph, diagrams, and statistics. So it's like a fact or a piece of data that is obtained from a study of large quantity of numerical data that we can say is a graph, or an event or person regarded as no more than a piece of data used to suggest inappropriately or impersonal approach, or he's just another statistic. Like thinking in terms of data, like if we are trying to analyze or understand some market trends, say for the sales of umbrella, whether people buy more umbrellas in the summer or during the winters. So we can obviously predict that they want it more to be in summer for protection from sun and even rain. In the winters it doesn't rain so much and they don't require much data. So the origin of this term statistics came from statistik, or it's a German word that came from under the late 18th century. From the word statistic came statistics. So this is the whole course, that whole syllabus or syllabi, which we'll be covering during the course of our lectures. So we'll be as I said earlier, that this is gonna be a really comprehensive course where even those people who are not from a statistical or a mathematical background, we have taken them into account, and we have designed this course especially for anyone and everyone having little or no prior experience in terms of statistics and looking to transition into data science, machine learning, or anything, and wants to learn statistics for that, which is the basis of all data science. Like probability and statistics are probability and statistics form the basis of data science. Without probability or statistics, nowadays data science can be done. So there are two kinds of statistics. There's a basic descriptive statistics, which provides us an overview of the attributes of a data set. So which means that it provides us some basic things like mean, what's the mean revenue, what's the mean revenue for each month, what's the median revenue, and what's the mode revenue. Mean is the average, median is the middle point, and mode is the most frequent occurring data. And the range, variance, and standard deviation. We'll be covering them in much more detail as we proceed further. And the second kind of statistic is inferential statistics, which provides a measure of how well your data supports your hypotheses, or something, some thesis that you have made based upon your assumptions or based upon the data that you have collected. How true is that? So that can be predicted with inferential statistics. So these provide a measure of how well your data support your hypotheses. If your data are generalized what was tested, these become significance tests. So the probability theory is very much helpful for making the predictions. So measurement of central tendency. So we say let's take a sample data set wherein we are having 2 red apple, 3 blue oranges, just for the scenario and an assumption. Well, there's 1 green ginger, and there are 2 yellow and 2 blacks. So we consider them to be color, fruits, vegetables. We can consider them to be anything. So this is our histogram. So we are trying to, histogram is just a visualizing. So we are trying to visualize them on a scale of our graph that we call as histogram. The correct definition of a histogram is, so histogram is a graphical display of data that's using bars. So we can see some bars over here of different heights. In a histogram, each bar group represent numbers and ranges. Taller bars show that more data falls in that range, and while the shorter bars says that less data falls into that range. So mean, what is mean? So the sum of the data points divided by the number of data points. So if we are trying to see what's the mean of red. So mean cannot be collected for just one of the data point. It can be collected for all of the data points. So say 2 plus 3 plus 1, 6 plus 2, 8, and 10 divided by 1, 2, 3, 4, 5. 10 divided by 5, that means 2. The mean number is 2 for our data. The mean number of fruits, if they were fruits, or the mean number of vegetables that's there in our basket is 2. We also call it as average. Then we come to the median. Median is the middlemost data point when data points are arrayed in a sequence, that is lowest to highest. And finally our mode is the most frequently occurring value. So this was all about the basic of statistics. We'll follow more in the coming tutorials. Hope you enjoyed this lecture. If you had any problems, you can leave them below in the comment section below. Thank you so much.